Guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. First, before we proceed, I would like to kindly request our members to subscribe to our channel and also engage us in the comment section. And I'd like also to request us to check our description boxes of various videos that we have uploaded, which of course consists of a link of topics under similar discussion. So in this case, we're going to look at the concept of solutions of linear equations. And particularly in our previous videos, I've defined the concept of a linear. Basically, I'm going to do it as I've defined the concept of a linear equation as an equation that is going to be of the form of a1x1 plus a2x2 plus a3x3, going in that specific order, of course, to an xn, and this is going to give a particular solution given in terms of B. Now, in this specific arrangement of a linear equation, the coefficients which I've given for one, A2, A3, are going to basically, so this is ranging to AN, are going to constitute what we refer to as constants. And this other part of the equation which I've given in terms of x1, x2, to xn are going to be referred to as variables, and we're going also to see that part of finding the solutions of these linear equations, of course, is going to determine this range of variables which I've given on the board. Now we're going to, of course, learn that particularly the solutions to an equation are going to be a set of ordered n tuple, which are going to be given in terms of course, this set given as C1, C2, C3, which is going to go to Cn, and therefore we can represent this specific combination of A1, C1 plus A2. I'd say that basically A represents a constant, C2 plus, and this is going to go on up to a point of An, Cn equivalent to B. So therefore, we are going to explore the relationship between these specific representations that we have given for the two sets for a solution and a system of a linear equation, which can be given in this specific case as such. Therefore, I'm going to give a specific illustration, and of course, that is going to assist us understand in a clearer way the set of what we refer to as solutions to a system of a linear equation. Now, in this case, if we have an equation of the form 5x 1 minus 3x 2, and of course plus 6x3, and minus 4x 4 in that specific case, equivalent to 10, we can have a set of numbers which are going to provide solutions to these specific variables. And if this set of numbers is going to be in agreement with this specific solution, then therefore it's going to form a set of solution to this, or a solution set to this specific, or a solution to this specific linear equation. And therefore I'm going to give this specific set of numbers for 3, and then we have 5, 3, and 2. Now, in this case, if we take this one as a solution of this specific linear equation, then therefore we're going to confirm that by doing a substitution for 3 minus 3 into 5 plus 6 into 3 going in that specific order, and minus 4 into 2 going in that specific order. So this is going to be given as 15 minus 15 plus 18, and then minus 8 given as such, and this is going to give us 10. So therefore, this specific range of numbers which I've given in this ordered way are going to form a particular solution to this linear equation given as such. Now we can have a different, or rather a set of linear equations, or a system of linear equations, whereby this particular system is going to be given in terms of a number of equations, as I'm going to illustrate, whereby a system of linear equation is going to be basically a collection of several linear equations. And of course, I'm going to give this one as an example, as I said. Now, a collection of those linear equations are going to have a solution to the system in terms of n variables. And of course, this is going as well to be in terms of n tuples. So in case we have perhaps 4 solutions, and then I've said that this basically is going to form what we refer to as So if we have four linear equations, this is going to form what we refer to as a system of linear equations. And I'd say that basically this system of linear equations is going to have specific solutions, which are basically going to be given in terms of perhaps can give this one a respective, of course, values which we are going to see later being given in that specific case. And of course, we're going to see that this is specific solution to systems of linear equations in n variables ranging from x1, x2, x3, etc. are going to be in n tuples. So in this case, they are given that specific illustration in terms of a C. And of course, these specific solutions are referred to as a set of a solution, just as I've illustrated on the board. So in this case, we're going to find a set of or solutions of systems of linear equation using specific examples. And in case a system, of course, is going to consist of solutions, then therefore we're going to see that this particular system is said to be consistent. And in case it has at least one solution, and of course if it does not have any solution, then therefore this particular system is going to be referred to as inconsistent. So therefore, as we go ahead, I'm going to be defining those specific examples in terms of consistent and non-consistent, whereby as I've said, for a system that contains at least a solution, that is going to be regarded as consistent, while a system that does not have a solution is referred to as inconsistent. So basically, catch us in our next video, which is of course going to be a follow-up video on this specific discussion. And we're going to use a set of linear equations and specific laws which are going to be accompanying this set of equations and trying to find solutions to those specific equations. So that is it for now, guys. Bye, God bless you. Catch us in our next video.